All right, but before we jump into that, now this is up, right? Does anybody have any questions they'd like to go over?
Can you go over the hypothesis one and hypothesis?
We're gonna go over that. Yeah, that's coming up. Anything else, like any homework questions y'all want to go over or anything?
Can you go over 2.1? Is that what you would need help with?
2.1?
Yeah, 2.1.
What from 2.1 did you need help with?
The first one. I'm trying.
What's the first one?
Because it's so easy, but and I didn't understand what
Mhm.
saying it's wrong.
Is it a multiple choice question? What is it? Okay. So I would have told you just guess. Hmm. Yeah, the Wi-Fi?
I'm trying to log into my Wi-Fi.
Not this. Your email.
Oh.
Not that one. Yeah.
So I had a number too and no
Oh, the
number.
one without the numbers. The one that's the first name dot last name at stu.bc.q, that one.
I don't know why it says this wrong. I literally wrote all the numbers down, and as I type it here, I marked
You have to
it.
pay attention to E though. See right here where it says equal to,
Yeah.
so that means 22 is equal to
Yeah,
this,
but
but
22
28 is
isn't.
not.
Oh, 22 isn't here.
That's
Oh,
fine.
28.
That's fine, but then also when you come down here, right? So 28 would be in this one, not that.
Yeah, I know. It's
Hoy 68.
Bien.
Yo no tiré. Yo pues no tiré 66.
14, 2, 4, and this is 5, 9, 10.
Pero tú no
Here.
yo estaba mal. Me jodí la espalda. Ahora porque yo regresé, yo me dieron mal después de no de
So you didn't see what's good.
Hiciste lo mismo en el teléfono. No te tengo la aplicación para
It's not check it.
It's 236.
Oh, really? Yeah, I don't even have it. It's not here, there's no.
Where's the other 36?
Yo depende de que pues no sirve. Y todo el mundo tiene.
Entonces, ¿cómo te puedo pasar la relación? No, pero por lo menos este es un tiempo que la que estaba allí, ¿viste? Ah, que no, que ya no va aquí.
Pero mi hermana.
Ya, bueno, ustedes son muy pendejas.
Mi hermana me dice que está bien.
This is actually an easy fix.
Porque ya la profesora no-
At the end of class, that's it. No, I'll go over that.
y vi que estaban bien, que no le importa. Al final, ¿quién?
No nos estamos viendo mucho de eso.
No, esto es lo uno. Lo que el departamento. ¿El departamento va a estar aquí? No, él va a estar por el departamento que lo bloquea. Es lo que lo revisa por la oficina. Puede ser. La semana pasada no está otro examen también. Pero examen. ¿Usted?
Last week,
Sí. ¿Y qué te pasa?
last Saturday? No, we don't do that.
Ah, sí.
Ah, pues son
Vamos a tratar de
Saturday.
hacer examen gratuito, vamos a decirle que no lo veo y nos sentamos y tú chile, yo me siento aquí.
Adelante, para yo, porque
¿Y cómo yo voy a ver, pendejo? Ay, padre.
Pero sé que hay que venir, porque la semana pasada con un examen también, más duro que ya.
Is this still in your classroom?
Soy el último de feo. Yo odio esta clase, esta es la segunda vez que yo la pongo.
No, el último va a ser el resumen de lo.
It says Erica figuring out.
Sí, pero a mí me dijeron que hay una vaina que dice que va a caer la vaina que como que
Remember, this is your email password, not CUNY first.
Okay.
Yeah.
como si cae 52 y hay tanta tanto y tanta preguntas así como para
Probability.
And tell me how that goes.
que va a ser difícil.
Well, that was an error.
There was an error, so it went through?
It says failure, and it says unrecognizable.
Unrecognizable. We might need to ask IT then for that one, yeah. All right. Let's look at this question right here, right? So it says a certain type of seed has a 75% germination rate, right? If 15 seeds are planted, what is the probability that exactly 10 of them will germinate? Right? So let's look at what we have here. All right. So I have 75% germination rate. 15 seeds are planted. They want to know exactly 10 will germinate, right? So for A, what are they actually asking you? They want to know what is the probability of 10. That's what they're trying to ask you, right? What do you have? You have an N, which is 15. You have a probability of success, which is 75%, which we know is what? 0.75. Right? After that, you can just type that in the calculator, right? This is the what? The binomial PDF, right? Your trial is the same as your N, which in your case is 15. Your probability of success, that's going to be the 0.75. Or you could put 75%. You can do that too in your calculator as well if you want. And then your X, in this case, is just 10. Do it. Just do it in the binomial CDF. I mean PDF. Sorry. PDF, I'm sorry.
Is 13.
Mm-hmm. Success 0.75. Yeah, X is 10. What you got?
0.165.
That's all you got?
0.165.
What was it? 0.165 what?
0.165145981.
Okay. You got the same thing? So do it. So you go to second. Then you go to distribution. That's where the data button is. All right. And then you go down to binomial PDF. And then just enter in all those numbers there.
So X is 15,
Yeah, just
So-
copy.
You
X is
said
15.
second, what? Second, then data.
Then data,
Final PDF for 17.
yeah.
what is the stigma?
There is no sigma.
Me-
You're in the wrong one. Binomial. Binomial PDF. Not normal. What's up, man? Or binomial.
Trials. is
Binomial. It should literally say the word trials in your calculator.
I see it.
Yeah. Good. So what you got? Let me see. With the same one?
I see it's trading, because I don't see trying.
Good. I'm done. Trace. I see trace. I don't know what trace is.
Oh, you said you want to do
Well, show me what you got.
it?
Ah, that ain't gonna help you.
It ain't.
They don't got it built in. You have to do it by hand. Trust me, you don't even want to see what this formula look like by hand. Mhm. Yeah, this joint is like mad fractions on a whole nother level. All right, so that's how you do A. All right. For B, B says, what is the expected value, the expected number of of seeds that will germinate, right? Expected value, right? You remember is what? That's our E of X, which is the same as our mu, is equal to N times P, right? What's my N? N is my trials. That's 15 times my probability of success, which is what? The 0.75. Yeah,
I was right.
it was.
The third.
Mm-hmm. And then all you have to do, just multiply them together, and that's it. 11.25.
Now you want to get easy questions.
I mean, it's the same question. I just copied
Now
and
we
pasted.
understand it.
All right, so this is expected value right here. All right. Next, I'm going to ask you for the standard deviation. All right. So the standard deviation, sigma, let me try that again. Yeah, that's better. Sigma is equal to the square root of N times P times 1 minus P. All right. Just plug it in. Nothing crazy here, right? This is going to be the square root of, what was that, my N again? 15
Yeah.
times the 0.75 times 1 minus the 0.75. Now, whatever the calculator gives you, that's the answer. What you guys got? Just type it in the same way it looks. You don't gotta do anything fancy. Is glare bothering anybody, or are we good? Good? Y'all want this slide on?
7050980.
Say it one more time.
1.6
Uh-huh.
77050980.
All right. Everybody else got that? Mike can verify. Nobody else got that?
And I'll call it 770.
All right. So that's good.
What, two? Said three.
Oh, 3? All right. So we good on this question? This is our expected value question. Good? Actually, this is our binomial distribution question I meant to say. Let me add another part to this real quick. Just because I'm looking at the question, I don't quite like how it's so easy. Let's say that I wanted to know what is the probability of X less than 5. Just making this up, right? X less than 5. For this one, right, you would use the CDF, right? Binomial CDF, right? And then same game, trials. This is going to be 15. Probability of success. That's going to be 0.75. Just trying to remember. Right? But now this says the numbers that are less than 5. Right? So numbers less than 5 are what? 4, 3, 2, 1, 0. Right? So your X here would be 4. And what CDF does, remember, CDF does everything less than but added up together. So it sums all those numbers that are less than, right? So this is the same thing as probability of 4 plus probability of 3 plus skip a few all the way down to probability of 0. I'm showing you this because there's a possibility that on your final, you might have a question where it might not just be, oh, what is the probability of one particular number? It might be a few numbers together, like a less than or a greater than. And this is what you use for that. Right? If it's less than, you're straight. You have it with this. If it's greater than, right, then you have to find the answer and then subtract it from 1. And that's it. All right. Somebody do this real quick. Give me the answer for this. That's what you're doing, binomial CDF. You're not doing it.
PDF, right?
Mm-hmm. One nine what?
1919. Me, 919. Sorry, erase the one, erase the 9.
Okay.
It's 919.
Okay.
Wait, it's not 0.75 multiplied by 4 plus 0.75 multiplied by 3. So this is 0.
No. That's a permutation. That's something else. Yeah.
How you do that?
This one, just go in the
Yeah.
calculator. Do that.
Put the P in the phone.
So what you do is you go down to binomial CDF,
Oh,
the CDF. So go second, then you go to distribution, that's where the data button is. And then go down to where it says binomial CDF. And then when you're down there, you just enter in all these numbers and then that's it.
yeah, this ain't the calculator for that.
Yeah, huh?
This ain't it for that.
3.905.
Yeah,
I don't know.
3.905. Let's see what I get. I got a 0. So what y'all doing wrong?
I got 0.00.
That's right. Yeah, that's it. What y'all doing wrong? No, he's right. So I'm saying, what are you guys doing wrong in your calculus that you're not getting that? It's the time to correct it now. Next week is the final. Right?
I think this is not good one.
That's right.
Eh?
Yeah. Apple will fuck you up on that final. Don't trust Apple. I'll tell you that right now. You know?
That second,
Uh-huh.
Then nothing else pops up.
Distribution.
Where?
Right there. Distribution.
This?
Yeah. Versus data. Yeah. And go across the distribution. And go down to binomial CDF.
Oh, wow.
And then enter. Enter. And then enter all the numbers. Right there.
Right there?
Yeah.
7.5.
So it says trials, P success, all that. And enter, then boom. Light work.
so it's gonna do the
Mhm.
work.
It does. That's all I'm looking for. So final answer 0.000115. However, it's so many zeros that I would actually accept
Oh, 0, 0.
if you gave me 0. Yeah. And that's it. So remember what? Yeah. Because it's a lot of zeros there, you know? But remember, what this means is it's taking the probability of 4, 3, 2, 1, all the way to just adding all of them together to get this number here, right? That's what's going on. Right. That being said, you guys try. Y'all can talk and work together if y'all want to.
So that'll be the bottom, that'll be N,
Mm-hmm.
right?
Mm-hmm.
Probability will be 5. 0.5, 0.5, 0.5. The probability,
Mm-hmm.
so now I have to figure out what's X.
Mm-hmm. It's in the question.
Two sides will be 2.
Coin has two sides, right? So 1/2, right? Mm-hmm.
So that'll be X.
Mm-hmm.
Yeah.
Definitely.
Let's see, what might, these are my corrections?
No, it's not your fraction. We're gonna get to that yet.
No, this is the other test, right?
Mm-hmm.
This is the third test?
I'll call you back.
Once again.
Really? Jordy. Y'all quiet. That means y'all done with everything? Malik? Devon? Oh,
It doesn't
man.
have to put- it doesn't have to put X 1/2. So it would be 0.5,
X1?
because these are 2 coins with 2 sides, basically, right? So you said it would be 1/2.
Hmm?
That would be X, but it doesn't let me put that.
Not X. No.
Huh?
What is 1/2? Or 0.5? Or what is that?
0.5.
Right, but which one is that gonna be? Is that your trial? Is that your probability of success, or is that your X?
The N is will be 8,
Um,
huh?
mm-hmm.
So then that will be the probability of success.
Good. Esther. Welcome. Joanna. Joanna.
Es que ahora está con el tiempo. No, pero yo lo digo exactamente, porque no me tengo que tomar. Ajá, pero en todos lados. Y ese, mira ese como está. No, esa
Not bad.
I don't like that. Why do you have it like that?
I do that to everybody.
How about this?
It's better, actually. It is.
Tiene como el teléfono. De otra, como el teléfono.
Marijuana. Here. Toby. Down here. Hmm? I didn't? On the first page, you don't see a grade? That means it's wrong, then, if it's like no grade on the first page. No, then that's not it then. Yeah. We'll look over it. 1 second. I'll look over it in 1 second. Chelsea, come here. Stephanie.
That's the highest in the row.
That's not bad though.
Grade so far, like not averaging the final.
So it's about 76.
What is that to be?
C plus. Okay.
How can I get a B?
You can.
How?
You better on the final.
Hmm?
You better on the final.
What grade do I need to get?
Get 100.
It-
And I give you 100 in class.
If I get 100 on the finals, I could barely get a, a C.
That's correction, exactly. You should, on the back.
I don't understand why, if I'm getting all these checked out, I don't understand why I still keep getting these low grades. I don't understand why I'm talking about.
There's nothing wrong, just probably stuff missing. For some of you, that's what I see on the test. It's not wrong, it's just missing stuff.
What is this mean? We just opened your mouth. I mean, not in talk, but we discussed this on the final.
You got full credit for that.
Oh, this is full credit?
Yeah,
So that was 2.5.
that's 25.
But what am I missing here?
A lot. We're gonna talk about that. It's not just you. A lot of people missing a lot on that.
So that allowed me to get this grade.
Mm-hmm.
But you didn't grade this question.
Because nothing was right here.
I graded you the professor.
That's not all of it, bro.
Huh?
That's not all of it.
But still,
Where's B? B is the most important part. That's why. All right, you can bring it up. Let's go to the. Mhm. So look, let's check this out. A fair coin is flipped 8 times, all right? So my N is 8. And it's a coin, right? So my probability of success is 0.5. Or if you want to say 1/2, same thing, whatever. All right. They want to know for A, what is the probability of getting exactly 5 heads, right? So for A, what is the probability of X equals 5? Right? Not so bad. So you already know. Binomial, PDF, all right? My trials. What's that? 8, right? Remember, trials is the same thing as your N. My probability of success. That's going to be the 0.5. And my X is the 5. Plug it in the calculator, enter. All right, what do you guys get?
0.855.
So I heard 0.855. Do we agree? You got that too? So the next question, part B, is asking you for your expected value, right? So expected value, also called E of X, is equal to our mu, which is N times P. And what's my N, right? My N was 8. And what's my probability of success? This was 0.5. Multiply those together, you get what? 4. Everybody got that? Good. A, sure. So for A, they ask, what is the probability of getting exactly 5 heads? Right? So that essentially asks you, what is the probability of X equals to 5? All right? So you just do the binomial PDF to get it in the calculator. No, binomial PDF in the calculator. Where's your calculator? You haven't had one this whole time? Yeah, you could borrow from the library. That's fine too. Yeah. All right. So if you borrow from the calculator, from the library, excuse me, you would go to second, and then you'll go to distribution, DISTR, right? You go down to where it says binomial PDF, right? And then you enter it in the same order, right? NPR, right? 8, comma, 0.5, comma, 5, close parentheses, enter, and it gives you the answer. And then that's it. And then for expected value, just multiply the two of them together. That's it. Go ahead. Put number wrong. Which one you?
The 15 for the trial, well, from the last one,
Yeah.
it's actually 0.21875.
So 0.21875. Okay. We all got that? You got that too? All right. Last but not least, for C, what is your standard deviation, right? Remember, standard deviation is the square root of N times P times 1 minus P. Just plug it in, right? It's going to be the square root of the 8 times 0.5 times 1 minus the 0.5. By the way, you don't have to memorize any of this. This is all on your formula sheet. Copying straight from your formula sheet. This chapter 6 right here. All right, not making any of this up. All right, just plug it in. Boom, boom, boom. What y'all get?
You can also use password.
You can use that. Yeah, that's legal as well. Those of you depending on Apple, that's what y'all have to do is depend on that table. The table. So it's more work by hand. in other words. But it is possible. So type this in real quick. Tell me what you get.
Can't get out the.
Second quit. So I heard 1.41 around it. Okay. Anybody can confirm? So that's 8 times 0.5 times 0.5. Square root, of course. What about that? Basically the square root of 2. That's what it basically is.
25 times 1 minus 25.
Yeah.
I got 1.87.
1.87. A little bit different than what we heard. Let me see. 1.41.
Yeah.
Okay. Let me see.
One minus 25. Oh, I can put it.
Yeah, I got the 4141.
Yeah.
Got you. Yeah, that parenthesis thing matters. Really important, you know?
Oh, for the one.
Yeah. Questions on this? We good? So when we go on the final, we see the binomial question. We gonna get that right, right? The calculator died? All right, you have the charger for it? So, got you. I know. If you had I could plug it in over here, you know? Let me see.
There's something no
Yeah,
gas.
that's
It's
what
not-
goes around it. Like this. Might be able to help you out.
Four sides and everything.
Give it a minute. All right. All right, so anyway, we good? All right, let's look at the next question. This is the next question that's going to be on your final, right? The time it takes for a mechanic to change the oil in a car follows a normal distribution. That's the key word. With a mean of 20 minutes and a standard deviation of 5 minutes, what is the probability that a randomly selected oil change takes less than 15 minutes? Simple, right? Let's look at what we have. This is a normal distribution. So whenever I hear normal distribution, I should be thinking of what letter in the alphabet? X, no. Z, right? Normal distribution Z, right? We have a mean of 20 minutes and standard deviation of 5 minutes, right? On your test, this example won't be so vague, where it's just saying mean is 20 and standard deviation is 5. It will tell you mu is equal to 20 and sigma is equal to 5. It will be very clear in that way. Yeah. Yeah, it's gonna tell you the actual symbol. Yeah. All right. Although, not gonna lie, on last test, the symbols was there, and y'all still, some of y'all, it was right there, you know? All right, so look, mu is 20, sigma is 5. Right? A says, what is the probability, right, that X will be less than 15? Just to be clear, I'm getting that from right here. Less than 15, right? Maybe that's a little too dark. Like that better. Less than 15. So change your X into a Z, right? So what's our Z formula again? Again, I'm not making this up. Straight copy from the formula sheet. It's chapter 7, right? X minus mu over sigma over the square root of n. That's it. Then you just plug it in, right? This is going to become probability of Z less than, what's my X? 15 minus my mu, which is, ooh, hold up. Wrong formula. This is it. 15 minus a 20, all divided by my sigma, which is 5. So the calculator on that, what does this equal to? Probability of Z less than, what's that? Negative 5 over 5. Perfect. So I'm going to say negative 1.00. That's for all those who refuse to use a calculator. All them Apple heads in here. Yeah, I know y'all have to use a table for that. For us though, right? Norm, CDF, right? This is a normal distribution. Remember, normal Z, right? So we go to normal CDF. First thing they're gonna ask you, what's your mean? For this situation, right? Since we already switched it over, our mean is 0. Our standard deviation, I ran out of space. That's why I'm doing it like that. It's going to be 1. My lower bound is what, and my upper bound is what? Now, what did I forget to do here? I forgot to draw my distribution. All right? So let's draw the distribution so that we can remember what we're doing here. So remember, in the middle is my mean, which is 0. And negative 1 is going to be to the left over here. That's negative 1, right? Now I want the area to the left of negative 1. So I want the area over here. Right? Now pretend that I'm standing right here. Right? To my left, right, is my lower bound. To my right is my upper bound. Always. To my left is my lower bound. To the right is my upper bound. This would be infinity, or actually negative infinity, excuse me, which remember is the same thing as the negative 1e99. That's already in your calculator. That's your lower bound, negative 1e99. All right. What's your upper bound? That's a negative 1. Press enter, give me the answer. That's it.
First one.
Yeah, what?
I'm gonna set the upper bound.
I'll be honest with you. Since y'all got the right calculator, y'all could just jump to this. Like draw the picture jump to this, I'll give you full credit for that. But for those that don't have it, the calculator, they have to go through this process to get it. So-
So for these questions, I had to draw I had to draw the
This
graph.
is a hypothesis test.
A
And you
hypothesis.
did what you call a confidence interview, that's why.
Okay.
Mhm.
The upper bound is the same thing as the standard deviation?
No.
How do you get the upper bound?
So imagine that you're here, right? The upper bound is whatever's to your right. And the lower bound is whatever's to your left. That's
The
what
lower
that
bound is always the.
To the right.
negative one,
Yeah.
and,
In this situation, right? If it was greater than, the lower bound would be an actual, the lower bound would be a number and the upper bound would be infinity.
okay.
29, it depends.
Okay.
Yeah.
I'll make it -5 over 5.
15 minus 20 over 5. Like, it goes like this. And then-
Minus.
Yeah.
I get -1.
Yeah, -1. Yeah.
Plus.
-5 over 5 is -1, right? Yeah. Yeah, so this is one of the questions that's going to be there. Let's look at question 2. Question 2 says, right? What is the probability that the average oil change time for a sample of 30 cars? That's the difference right here. Now I have a sample of 30 cars. Is between 19 and 22 minutes. All right? So between 19 and 22 minutes. Let's take a look at that. Oh, wait. I didn't even get an answer for this, though. What's the answer for over here? Nobody even told me.
0.1586556.
Like that?
0.158. No, yeah, the rest of the numbers right. That's taking 5 right there.
0.158. Okay. Everybody else got that? No? You can even look it up on the chart and tell me. Right? The formula sheet, yeah. Normal distribution. You got 2. When you got -5 divided by 5, you got 2. Okay. Use a formula sheet then. Go to normal distribution, right? Go to -1.0 and go across to where the 0 is. What number do you see there?
One point eight seven.
Good. Full credit. All right. You can use a table or you can use a calculator for that. Let's look at B. Mhm. Yeah. But I'm giving you the final questions now. So n is equal to 30, right? For part B. And we want to know what's the probability between 19 and 22. Let me just verify that. Okay. So boom. All right. for you guys with the right calculator, right? If y'all want to save time, you guys can just jump straight to the graph and then just give me the answer from there, right? So let's look at the graph real quick. The mean was 20, right? So if I have a distribution like so, we know that our mean in the middle is 20, right? So where's 19? On the left-hand side of 20, right? That's 19. And where's 22? On the right-hand side of 20, right? So I want this area in between right here. So in your calculator, you can go straight to, so norm, is it normal? Yeah, normal CDF. Mean is 20. Standard deviation, right? A little bit more complicated though. Our standard deviation, a little bit more complicated, right? So anytime we have an N, right? Our mean changes to a mean for X bar distribution, right? Which just means that it stays the same. Nothing changes there. But for our standard deviation, that's going to change to a standard deviation for X bar distribution. So what that means is that we have to find the sigma over the square root of N, that formula, right? And then you just plug it in. I forgot what sigma was. Hold on one second. 5, right? So this is going to be 5 over the square root of 30, right? Whatever answer you get there, that's your standard deviation over here now. All right? So what's 5 over the square root of 30? So 0.91. Everybody confirms? What y'all got? It's just 5 divided by 0.09. So 0.91, that's what you're saying? Okay. How about you? What you got? Okay, type it in. Let's see. So I got 912807. Nine one two eight seven one. That's what I got. So 0.912871. Now remember, if I'm doing this distribution right here, right? To my left is the 19. Lower bound is going to be 19. Upper bound will be 22. Press enter, give me the answer. All right. You have the proper calculator, this is simple. If you don't have the proper calculator, you got to go through that process that you saw in the first one with a different formula. So we're going to do this again and I'll show you. So what's the calculator say? 8491. So, everybody else got that?
0.491102, yeah.
You got that too? Awesome. Awesome. You got it? All right. Good, good. Huh? I'll take it. I'll take that. All right. So that's provided that you have the calculator. If you don't have the proper calculator, right? What you have to do then, you got to go through the motions, right? You have 19 less than x less than 22. Change that x into a z, right? This is going to be what? X bar minus mu over sigma over the square root of n less than less than z less than x bar minus mu over sigma over the square root of n. Plug in all those numbers. This is going to be the 19 minus the mean, which was 20, over the standard deviation, which I believe is 5, right? Over the square root of 30, less than, shoot, I keep saying that, less than z, less than the 22 minus 20, over 5 over the square root of 30. Plug in the numbers, get the two z values, right? When you find the two z values, what's going to happen is you're going to have to look those up on the chart and subtract those two values from one another to get the final answer, right? That's if you don't have the calculator. So let's do that real quick. So I have a probability of negative 1 point, let's just say 10 for this. Less than z, less than 2.19. And then what you have to do individually, look them both up. This is z less than 2.19 minus the probability of z less than negative 1.10. You look up those two answers in the table, subtract them from one another, and you'll end up back with the answer that we got up top. And that's how you do it. If you don't have the calculator, all right? More work, lots of fun. Here, you guys try. Try that out. This is our chapter 7 question. That'll be on the test. Mhm. Pay attention to the key words. Remember to copy your formula in chapter 7 if needed.
Come on, X would be like 10.
It's in the question. Y'all good? Hmm? Got you. Yeah, I got nothing on me. I got nothing on me. But in Colston Hall, if you know when you walk in a Colston Hall, you go around the corner, they have this weird machine, starts with a V. Vingo, Vin something. They have stuff there. I can't pronounce the name of the machine, but you would notice it has like lights and stuff. They have it in Colston. Sure. All right, let's take a look. So the weights of newborn babies are. Wait, all right, I got you. Give me a minute. Okay. Why go for a B? You can get an A.
I'm gonna go for an A.
Yeah.
What is that stuff that you can do that you can, if, let's say I get an F, which I know I'm gonna get an F.
How you
What
know?
is, cause I know it's okay. But anyways, straight to the point. What is it that stuff that you can do that it doesn't show up on your, yeah.
That's drop. That's like a long time
No,
ago.
not drop, there's another thing you can do where you can only use it once.
Oh, you gotta pee for this.
No, that would still show up.
Professor, but for those who are like, you should give us like credit for at least attending class.
You're getting credit. No one else knows about that policy, just you guys.
I better not get C. No, I won't have to take the class again if I get a C. I don't want to take the class again. I got a C.
Why could I see? Get an A.
I'm like aiming for an A, I'm final.
I hate this class, I'm sorry.
Aim for an A plus and settle for A minus.
I know, I'm gonna aim for an A, but I really can't get a C.
Alright, so.
Hmm?
I'm stuck with everything.
Stuff? All right, let's look.
I'm stuck at the drawing. The lower band and the upper band.
I got you. So let's take a look. So the mean is 7.5 and our standard deviation is 1.2, right? So what is the probability that a randomly selected newborn weighs more than 9 pounds, right? So they want to know what is the probability of more than 9. Now we know probability of more than 9 is probability of X greater than 9. Right? That's simple. Right after that, you can go straight to your drawing if you want. You know your mean is what? 7.5 right here. So what I want to know is it's 9, right? 9 is bigger or smaller than 7.5? Bigger. Bigger, right? So it's gonna be on the right-hand side. And then I want to know about the area to the right of it, greater than, right? So I want to know about this area over here. That's what I want to know. So I'm standing right here. And remember, to my left is the lower bound always, to my right is the upper bound always, right? Yeah. So that being said, all right, you go to normal, CDF. The first thing they're gonna hit you with, what's the mean? Exactly. What's the standard deviation? 1.2. What's the lower bound? Nah, what's the number that's closest to it? To the shaded area? 9. And then what's your upper bound? Right, there's no upper bound, so that's the 1E99. And then that's it. Hit enter and that's it. And then hit enter, enter, boom, give me the answer.
Lower bound,
Whatever's to the left of you.
starting.
Right. No matter where you are in the picture, your lower bound is always to your left, your upper bound is always to the right. Always. Mm-hmm.
I was trying to figure out what was the upper and lower bound.
Got you.
0.105649.
498. Okay, I'll take it. All right. Now, say you don't have the calculator, right? What you have to do from where you found out that the probability of X is greater than 9. By the way, this is the right answer. So for most of y'all done at this point, right? But if you don't have the calculator, right? What you have to do is you have to switch this X value into a Z value, right? This becomes, huh? Right. You have to switch it to a normal distribution so that you can use the table to give you your answer, right? So this is going to be the probability of Z greater than X minus mu over sigma. And then you just plug in all the numbers. So this becomes probability of Z greater than 9 minus, what's the mean? 7.5 over 1.2. What does it come out to?
1.25.
Okay. This becomes probability of Z. Yeah, it's 1.25.
Well, sometimes choose two, which means we have to divide 1.25 by 2 as well.
1.25 by 1.2, yeah. Let me see. I'll verify. I have 9 minus 7.5 divided by 1.2.
Becomes like 1.5 and then.
Divide that by 1.2. Got you. Yeah, I got 1.25 also. For which one? The top?
1.25 divided by 2.
No. It's just this. This is all you're typing in. That's all. Yeah, that's all you typing in is that. Yeah.
Problem is 1.0416.
What you doing?
I'm getting an F, so I might as well.
How you know already?
I know.
What you mean?
I'm fine with A, I'm not paying.
That's what I'm saying. There's still a chance. All right. So what you do after that, you're gonna look it up on the chart. But remember that your chart cannot give you probabilities that are greater than. It can only give you probabilities that are less than. So Hmm?
If you pass the test, you classify, and you pass the class, right?
Yeah.
So then once you got that,
So this is gonna become 1 minus the probability of z less than 1.25. So for you, you would look it up in the table, and then you would have to do 1 minus whatever the table told you, which is 0 point whatever. You know? So look up 1.25. Look it up.
I'm just standing because I don't feel right.
I understand. I understand. It's all good. You need chocolate. You need chocolate. I feel like it will help. Yeah.
1849.
All right, 8849. And then in the calculator, when you do 1 minus 0.8849, you get the same answer we get. And that's how you do it. Um, 1151. We got 1056.
It's not pretty much because you immediately equal, it's not say one was going to have above one. 1.5 is not minus 7.5.
9 minus 7.5 divided by 1.2.
Minus it's 1.5, 1.5 above 1.2.
Yes. That becomes 1.25. Yeah. Yeah. So I got 0.8944 when I did it. 1.25. 1.2, I'm close to where the 5 is.
Okay. I did the first one.
But that should fix it. A little detail kind of matters, you know? So that's our normal distribution question. When we see that, we're going to get that right, right? Right? Okay. Since y'all just took a test on this, I'm gonna let y'all try this for like 5 seconds before I go over it. But this, let's chat. Come on.
Out of there.
Yeah, so, see you guys next week, we're probably at 5.
Get on.
Y'all pretty much done with this, right? Huh?
So I was looking at my test, I didn't even look at. The same. So,
Let's see this real quick. So a random sample of 10 grocery stores. Ten grocery stores was taken to estimate the average price of a gallon of milk. The sample mean was found to be $3.50, right? On your test, it'll actually do like X bar. So you don't got to worry about like just the words and stuff like that. Okay. With the sample standard deviation of 25 cents, right? Assuming the prices are normally distributed, right? Construct a 90% confidence interval for the population mean price of a gallon of milk, right? First, it says to find the critical value for T, right? How do I know that this is a T critical? Because I don't know what sigma is, right? I have sample standard deviation here. All right. So let's recap what I have, right? I have n is equal to 10. I have x bar is equal to 350. I have my S, my sample standard deviation is equal to 25 cents. I have a confidence level of 90. Right? So because I don't know what sigma is, this is a T distribution. Right? What do I want to do next? So for T critical, I'm really looking for T of 90%. Right? Remember that in order for me to do T critical, I have to have my degrees of freedom, which is n minus 1. In this case, 10 minus 1. Call that 9. Right? And then we just look that up in the chart. Tell me what T critical is. 1.645. That doesn't sound right. Somebody confirm that for me. Which one is that? Yeah. Hey, what's up, man? 1.833. 1.833. That sounds a lot better. Do we all agree? Somebody else confirm that? So anybody else got that? Got that 1.833? All right. So now we could do our margin of error, right? Not making this up, just copying it straight from the formula sheet. This is chapter 8, right? So E is equal to T critical times the sample standard deviation divided by the square root of n. Just plug it in, right? Real simple. Just plug it in, right? So I have 0.25 over the square root of 10 times the 1.833, right? Somebody give me that number. Easy, right? Wait, 0.144 what?
No.
Okay. I will take that. And then now we want that formula at the top, right? The formula at the top, which is X bar minus E less than mu less than X bar plus E. Just plug in the numbers. That's it. All right. 350 minus your margin of error less than mu less than the 350 plus your margin of error. Little calculator, and you get your answer. Somebody do that for me real quick.
Big one, please, one.
3.351. An upper boundary. It's a 3.6449, something like that. Alright. Since we're talking about money, let's make this 3.36 less than mu less than 3.64. That's it. Questions on this?
Part B.
That's the whole part. That's the whole thing. Yeah. That's the whole question. The confidence interval.
This chapter 8, so.
Chapter 8, yeah. On your test, this was all I was looking for. Part A gave you the answer already. I wasn't asking you to verify it. I was just asking for this.
Number 3.
1 and
And
2. Yeah.
And
Question 1 and 2.
Oh, we going over the test?
No. We're going over the final right now. Mhm. You can still go to tutoring with that and get half your points back and all of that.
Going over both.
Yeah.
Yeah, I remember this week.
Everything's been posted already. Just
Oh, okay.
finish whatever is there.
So if you did like last week and you're caught up.
You're good. Yeah. As long as it says 100, does it say 100 at the bottom?
Yeah.
All right, you're good.
Double check out.
Yeah. Here, you guys try. After we finish today, you guys will have seen every single question that's going to be on the final. All right. I will also post a picture of the study halls that are going to be going on next week. You guys are welcome to go to one, two, or all of them if you want. Right? In the study halls, they're going to be doing something similar to what I just did with you guys, where they're going to go over every single question step by step and how to do it. All right. So if you want to see the same thing again, go ahead. You know, the review sheet for the final was also posted in the last announcement. I'm posted again in this announcement. In case you guys want to go through that again, it's fine as well. You know, it should be all good. If we really tally it up, right? I would say if you put all your homework together, that's like your first time seeing the final. If you put all the examples from class together, that's the second time seeing the final. If you look at all the review sheets for the test, put them all together, that's your third time seeing the final. Put all your tests, all three tests together, that's your fourth time seeing the final, right? If you look at this review thing that I'm doing this twice, right? Because I'm doing it once and I'm showing you guys and letting you guys do it right after. That's your what? Your sixth time seeing the final. You go to one of them review classes, that's like 7, 8. You go to 2, that's 9, 10. You know, in high school for the Regents, they only gave y'all 5 practice finals. That's like 10 y'all have access to. You know? So y'all could pass this. There's no reason y'all can't get an A if y'all don't want to. Yeah. Do you know where it is?
It's on the cafeteria building.
The third floor. You want your calculator? It's not fully charged, but it has some energy. You know. So, all right. Check out the recording, and see what you think. For this, we got just 2 more questions and then y'all good to go. So like when you're studying, it'd be like this week's video and last week's video, and then that's the final right there. It's drawn out a little bit because we have the test in between, and then also like I'm giving how you doing, man? Also I'm giving you guys like time to like try it and stuff like that. So that's why it's a little bit drawn out. Mhm. Mhm. Also, I heard that tutoring will be open regular hours next week. 11 to 8, Monday through Thursday. This is both in person and online. And then Friday and Saturday, 12 to 6. I mean, the Saturday not really gonna help y'all next week, but like,
Because
Yeah.
next week's the test, right?
yeah,
Next week Saturday?
yeah.
Yeah.
Unless y'all want to do a last minute test correction or after the test or something, y'all could do that, right? Yeah. Yeah. And there's no classes next week, so it shouldn't kill y'all schedules or nothing, you know. On Tuesday? Yeah, so come right after. Yeah, yeah.
Ready to be in the building?
Yeah, might as well, you know? Yeah. Yo, how about that NBA Cup though, yo? OMG. Damn Atlanta, yo. Yo. I'm not going front. When the game started, I was talking mad smack. And then in the end, I was just quiet, like oh man. Let's see. Go ahead.
I see my calculator does it sometimes.
Oh, I got you. So it's simplifying it radically. Just press that button right above. And we good to go. Yes. I got you. Yeah. So a random sample, 15 light bulbs was taken to estimate the average lifespan. The sample mean was found to be 850 hours with a sample standard deviation of 50 hours. Assuming the lifespans are normally distributed, construct a 95% confidence interval for the population mean lifespan, right? So let's look at what we have. I have a sample of 15. My X bar is 850. My sample standard deviation is 50. And I have a confidence level of 95%. Now, right. Now I need a degrees of freedom because I'm gonna use the T distribution, right? Because I don't know what sigma is, right? So my degrees of freedom,
And we don't know what system.
right? We don't know what sigma is. We know what S is.
I thought they moved it.
No, that's sample standard deviation.
Got it.
Yeah, see? Sample standard deviation. Right? Notice how, like, when I gave y'all tests, right? Y'all didn't see sigma there.
No.
Y'all not seeing sigma here. So what's that mean it's gonna be on the
So
final?
we just straight up just say the signal is this.
It would say that, but what does that mean for your final?
For everybody.
No signal here.
Exactly.
Yes.
Right? So n minus 1, this is gonna be 15 minus 1. Call that 14. All right. So now I want to find my margin of error. That's my E formula, right?
Yeah.
This is for T critical times the sample standard deviation divided by the square root of n. Now I know what the sample standard deviation is, that's 50, over the square root of n, that's 15, but I don't know what T critical is. That's my issue, right? I got to figure that out. So for T critical, I'm really looking for T of 95. 2.135?
Oh. That's the.
Yeah, that's a student T distribution right there.
I mean, no.
Yeah.
I looked at the
2.135?
15, the 14.
2.145.
15, the 14.
What you got? You got it too?
What, the TC?
The degrees of freedom. All right. So plug it in. Give me that answer. 27.69. That's 50 times the 2 point divided by the square root of 15. Okay. So 20.179. Like that. Yeah, 50 divided by the square root of 15 times 2.145. Mhm.
27.69.
27.69.
Wow.
0.69, 183.
Yeah.
Okay. So once you have your margin of error, you already know I want that final formula. X bar minus E less than mu less than X bar plus E. Right? What's my X bar? 850 minus the 27.69183 less than mu less than the 850 plus the 27.691. You get the idea, right? Do the math on it. What do you get?
The lower boundary, I got 822.30.
And upper bound, what's that? 877.
Yep, 877.69.
There we go. Right? Yeah. And then that's it. That's all I'm looking for this.
So that would have been that right there, the way you were looking for?
Mm-hmm.
Yeah.
Yeah.
That's full credit.
Not so bad.
Really?
Like that job is not so bad.
Like, I'm not gonna front though, like for you though, right? You was right there. You just didn't give me this. Like you stopped here. You didn't give that, give me that. That was the only thing.
Oh,
Yeah.
wait.
Yeah.
So you want to like that one?
Like you see how this is like minus?
Yeah.
And then we have the number here.
Yeah.
Yeah, like I want that.
Oh,
Yeah.
yeah. I'm about to say.
Yeah.
I stopped all the way at the T score.
Nah, keep going. This is all I wanted right here.
This is and that was number 2 on the plan.
1 and 2.
Yes.
Yeah,
Oh, okay. I get it.
yeah,
Yeah, I see it.
yeah. It was almost there, almost there.
You don't mind if like
Huh?
you did it like I did it the way I did it. You don't mind if I did it like that?
Mhm.
I'm usually used to something like that. I just eat combos. I'll look for it.
All right, let's look at this question. I already know. A manufacturer claims, keyword, that their light bulbs have an average lifespan of 1,000 hours. A consumer advocacy group wants to test this claim. They randomly select 25 light bulbs and find that the sample mean lifespan is 980 hours with a sample standard deviation of 50 hours. Assuming that the lifespans are normally distributed, right? Test the manufacturer's claim at 0.05 level of significance. Hold on. Don't quite like the way that this is worded, but it should say that you believe, right, that the manufacturer's claim is less than, right? So that's what you want to test. All right. Can't say I like the way that this was worded, this question. Anyway, let's go through it, right? So they claim hold on. Get rid of that. Okay. They claim to have a light bulb of 1,000 hours. They randomly select 25 light bulbs. Has a sample mean of 908, sample standard deviation. Oh. Nope. Hold up. Don't like this question. Don't like this question at all. Never mind. One second. Let me find a more appropriate question in the meantime. I'm gonna come back to that question or a question like that. In the meantime, let's do the scatter diagram and then I'll come back to that question. All right. Here go our scatter diagram real quick. Sorry about that. The English in that question wasn't too kind. All right. So no story here, just keeping it simple, right? You have a set of data, right? I want you to draw a scatter diagram. I want you to tell me if it's positive or negative, and I want you to interpret the answer. That's it. All right, 3 parts. All right. So this is how you draw the scatter diagram real quick. With a pen, not a highlighter. This is my x-axis, this is my y-axis. All right. So I look at my x's, I go from 10, I have 10, 15, 20, 25, 30. So I want to get from basically 10 to 30, right? Or 0 to 30, right? So I feel like I'm going to do that by, I can do it however I want. Let's do it by 5s.
Yeah.
Let's do it by 5s, right? I'm going to start off with 0 right here. This is 5, 10, 15, 20, 25, 30. Then I go look at my y's. For my y's, I have 25, 40, all the way up to 50, right? So I want to get from like 0 to 50, right? Yeah, I'm going to do it by 10. So let's do it by 10. All right. So 10, 20, 30, 40, 50, right? They don't got to be pretty, but just do your best, you know? And then each one of these are a pair. They go together, right? So this is 10, 25, right? So you come across the x-axis to 10, go up to where 25 is, you make a mark. That's a point right there, right? Then you do the next one. The next one is 15, 40. So you go across on the x-axis to where 15 is, and you go up to 40, you make a mark. I like X's. If y'all like dots, use dots. You know? No pressure there. Then next one is 20, 35. 20 and then 35. I think that's like somewhere here. Just do your best, not expecting it to be like stellar. 25 and 50. $30, $45. Okay. That's my scatter diagram. This is part A. Even though I forgot to type that here, right? The interpretation is part of the question as well. All right. So for part B, Would you say that this is a positive correlation or a negative correlation? Do not tell me zero. All right, that's not a real thing in real life. All right. What is that?
I'd say positive.
Positive? All right, good.
It's higher than where it started.
Well, it's because I think it's going up. It's going
Like
up.
that, right? That's the
It
trend
goes negative,
line
I think.
going down, right? So positive, yeah, it's not gonna be, it's not gonna be straight, but the idea is that where's it going to, right?
The flow.
So remember, this is your interpretation now, right? As X increases, Y decreases. As X increases, Y decreases, right? That's your interpretation. Okay? Questions on this? No? All right, you guys try this next one. Well, I find a better question for us to go over. Last week's video and this week's video to prepare for the final. It's gonna be 9 over here. Yeah, yeah. And then also there's the study halls. You're gonna see it in the update, right? Just go to 1 or 2. No, they're in person. Yeah, but
Today?
no, like throughout the week.
Oh,
Yeah, because there's no classes this week.
all right,
Yeah, so if you can go to 1, or if you want to go to all of them, go to all of them.
all right.
Yeah, sure. I'll see you. All right, try that in the meantime. Everything worked out at IT? Give y'all a few more minutes.
Why? Can you go by 2?
I want to get to 12. I'll probably do it by 2s. Yeah. But to be honest with you, you could do whatever you want. It's all right. Yeah. As long as you can get to the biggest number there on the list, then you straight. You know? So what's the interpretation as X is increasing, Y is decreasing? All right. Let me do it real quick. So everybody on the video can see. Sorry. Here we go. This is my X-axis, this is my Y-axis. So on X, I want to get to 25. I feel like I'm going to go by fives. So 5, 10, 15, 20, 25. My Y's, I'm going to go by twos up to 12, right? So 2, 4, 6, 8, 10, 12, right? And then you just, sorry. And then you just group them together, right? Remember that these are a pair, they go together. So then we're going to have 5, 12, right? Was the first one. So go to 5, go up to 12. Make your mark. Next one is 10, 8. We'll cross the 10, go up to 8. Make your mark. Next one is 15, 5. I'm going to go to 15, go up to 5. Make your mark. Next one's 20 and 2. Go to 20, then go up to 2. Make your mark. And 25 and 1. It's like, boom, like that. And that's it. So negative correlation, right? So negative. And as X increases, Y decreases. And that's it. All right. All right. Let's get back to that other question. I have another one that's better worded. Okay. So let X be a random variable that represents the hemoglobin counts in human blood measured in grams per milliliter. That should really be deciliter. Well, we're going to talk about that another time, right? In healthy adult females, X has an approximately normal distribution with a population mean mu is equal to 14.7 and a population standard deviation of sigma is equal to 2.7. Suppose a female patient had 15 blood tests over the past year, with the sample mean hemoglobin count was determined to be X bar is equal to 16.3, with the level of significance alpha is equal to 0.05. Determine whether the patient's hemoglobin count is higher than the population average. All right, let's look at what we have here real quick. Because there's a lot to unpack in this question. All right. So first off, this is a normal distribution. Right, we have a population mean mu is equal to 14.7. Population standard deviation of sigma is equal to 2.7, right? And then we have N for 15, right? And then we have our X bar, 16.3, and our alpha, 0.05. Let's write that down. So I have mu, 14.7, sigma, 2.7, right? I have N is equal to 15. X bar is 16.03. Excuse me, 16.3. Alpha 0.05. Okay. Here's where we first messed up. All right. First thing that I want. What is my null? What is my alternative hypothesis? That's step one. What is my null? What is my alternative hypothesis? Your null hypothesis, if you want to just keep it simple, is whatever the mean is. So mu equals 14.7. Let's just say we want to keep it simple, right? Your alternative hypothesis is the question that's being asked. That's your alternative hypothesis. So let's look. Here's the question. Determine whether the patient's hemoglobin count is higher than the population average. That's the question. That's your alternative hypothesis. So mu, one second. So mu is greater than 14.7. That's the first step, right? Second step. I want to know what kind of test this is, right? For your final, this is always going to be a, what kind of test? What test is this? Yes, a hypothesis. What kind of test? Z. Only learned one test. And the formula is X bar minus mu over sigma over the square root of n. Just plug in the numbers, right? Keep it simple. Just plug in the numbers, right? So X bar we know is 16.3 minus the mean, which is 14.7 over the standard deviation, which is 2.7 over the square root of n, which is 15. Little calculator, tell me what y'all get.
I agree. That's it.
295, what?
295,101,242.
I'll take it. All right. So that's my Z test, right?
You rounded?
If you want to. This next part. I don't know where some of this critical value stuff came from and all of that. Just find the p-value. It's so simple. The p-value is what? I want to know what the p-value of Z, and watch this. Whatever the alternative hypothesis is, the sign of the alternative hypothesis, that's the sign that's going to go in the p-value. Let me erase it.
For less than, greater than?
Greater.
Greater than?
It's very,
Right? That's it. Whatever they ask you in the alternative hypothesis, that sign is the same sign in the p-value. It's the same thing. That's it. All right. Now, what do we do after that? Y'all got the proper calculator, so y'all already know. Just draw the distribution. Just draw the distribution. This is 0. Over here is 2.295, whatever. And it's greater than. So you already know it's over here. That means that I'm standing right here. Right? So what does that mean? Normal CDF. What's my mean? What's the mean for Z? No, what's the mean for a Z? 0. And what's the standard deviation for a Z? Good. What's my lower bound? No. Remember, I'm standing in the middle. I'm right here.
Oh, yeah, 2.2.
Exactly.
Upper bound is okay.
And then this is the 1E99. And that's it. They just give me the answer.
That sucks. I ain't do the whole.
Yeah.
I need all them steps. I don't know.
Yeah.
No, lower bound is to the left, yeah. To the left of wherever I am. So to the left of me is that. And then to the right of me is infinity. Yeah.
The number is.
Yeah. So what's the answer?
0.0. 0.0 times. You got that from there?
Oh, no. I agree.
Yeah.
Mean is 0, yeah. Because we switch it into a Z. Right? So mean is 0, standard deviation is 1. Lower bound is 2 point whatever. Upper bound is infinity. Confirm this one for me. I want to know if this is right.
Yeah. 0.010866532.
I'll take that. Okay. Step 4. I want to know your p-value versus alpha. So I have 0.0108 versus the alpha, which is 0.05. Which one of these is bigger?
0.05.
Good. So if my p-value is less than my alpha, what do I do? What would Snoop Dogg do? Yeah. You remember that picture from 2 weeks ago of Snoop Dogg? What you mean? Yeah. Rejected, right? So when your p-value is less than alpha, you reject the null hypothesis. So step 5, I reject the null hypothesis. And if you want to give me an interpretation with it, right? So there is enough evidence to conclude that the null hypothesis is false. right? I will take just this, but if you want to give me that too, I'll take that too. All right?
I like to put it in line. I
Yeah.
put the P value, since P value is greater than this, we reject them all. That's what I.
Yeah,
I missed step 3 and 4, but everybody.
got you.
Maybe.
That wasn't just you, a lot of people did. Like
Yeah.
nobody got a whole hypothesis question right.
I remember you told us, you were like, oh, no one like got anything wrong, just missing.
Yeah.
You said.
And I'm pretty sure, didn't I tell y'all there was 5 steps,
I think
But yeah, he did tell us that.
right? And then after that, I told you there was 5 steps again, and then
Yeah.
5 steps again, and then 5 steps again, right?
Hey, man, I get it.
Cool.
for 5 questions and 1 problem.
Mm-hmm.
Yeah. That's why they're technically.
Here.
4 questions on the exam.
You guys try.
We have two.
Yeah, but not till 3.
Okay,
Yeah.
do you have a blank copy of the test too?
I'll give it to you in there. I got you. No problem. So go ahead, try this out real quick. Tutoring is open and we are on our last question. I'm giving you guys a chance to try this on your own. Feel you, man. When I was in like 2nd grade, it was like, yo, glasses. I'm like, damn. You know? Yeah. I don't know. I got used to them over time though.
I think for like a week and a half in high school.
Yeah.
And I was like, nah. I ain't that bad.
I mean, I ain't like it, but you know, it is what it is. I seen this video of this baby. It might have been on like Inside Edition or something. But yeah, like so this mother, she swore that her child couldn't see. I mean, she just swore, but this is like a baby, you know? So she brought the baby to like the doctor. The doctors was like, yeah, nah, we really can't tell if he can see or not, you know? And then she went to this other place that I guess you say that would listen to her. And then they actually made a glasses for the baby. And it's like the baby like started to be able to see. And you could see like the reaction of how everything was different, you know? Yeah. Something interesting that she said, you know how this is really bad, but you know how like kids when they're really young, they'll pick up something and they'll put it in their mouth off the floor and stuff like that. So like one sign that this baby couldn't see was that the baby was never doing that. And after the glasses, now it's like, you know, yeah. Not that I'm advocating for that though. Don't pick up off the floor. While we on the topic though, what was the rule again? Is it 5 second or 10 second rule? I forgot. It's 5 seconds.
They said 10-second rule is making it up.
Yo,
I remember, man, it's the 20-second rule. I'm like, nah.
Now you drag it.
20 seconds is a long time.
Where.
There's a class they got here. It's called Bio 28 Microbiology. That's gonna change your life if you take that, Junior, man.
Microbiology?
Yeah. People become paranoid after that class, yeah.
Everybody's telling me. I already don't like my chemistry class and everybody's telling me biology is gonna be Just as worse.
It's different. That's the best way I could put it. So, all right, I would rank sciences a little bit, right? I'll go from like biology to chemistry to physics, right? So bio to me is like history class, even though it's a science, right?
Right.
I feel like it's something like a dictionary class. Like you can look up the meaning of things and put it together and all of that, to get your answer and stuff like that. Right, Chemistry though, right, is like a cross between bio and physics. So now there is some of that where it's like you're looking at meanings and putting them together and all of that, but there's also like equations for you to figure out and stuff like that, like balancing the equations and stuff like that.
I mean, my
And then
class,
yeah, there's math in it. And then physics is like all of that, but just more math. Like it's not there's there's some definitions, but it's more so math than anything. So
and
yeah,
biology is the boring one.
it's not boring. Like biology is really interesting to be honest with you. It's just that it's definitions, Yeah. Anatomy's nice, yeah. Yeah. In anatomy, they're just like naming out the body parts, like that's the head, that's the heart, that's the foot.
I
Yeah,
think all the sciences that you're saying, just simply just loaded a lot of
yeah,
like fluff
yeah.
and then make it more difficult than it has to be in my opinion.
It could be. When you get into like higher level classes, they start to become more like not complex, but niche, like specific.
No,
Like when you take bio 11, right, you're learning about the cells and everything, but you learn like everything related to bio. So you learn about like animal cell, plant cell, all of this. But when you get into like higher levels of bio, like now it's like, all right, let's just focus on the animal cell, right? And then like, well, matter of fact, let's just focus on mammalians or something like that. Or if we're doing like plants, let's just focus on plants, like they get more specific.
I'll say like those
Yeah.
classes, they get smaller, but
Oh yeah,
but the information gets like a lot of way when you do.
yeah. Oh, sometimes some authors they write their books in such a way that even though the book might be an introductory course, it might have language in it that explains the upper level course, if you know how to decipher it. Depends on the major. What is your major? Nice.
Stress.
Nah, nursing is fire, man.
Once I get through, the stress to get to be what it is. And like, but I think as long as you study and you keep like on top of it.
Yeah, most definitely. Yeah. You out?
Yeah, need to make an appointment to go on.
Got you. You doing nursing too, right?
Nah, I'm education major.
Education, that's right. When you transferring?
Next semester. I already applied to leave.
Okay. For early childhood?
Yeah.
That's good. I have another student in another one of my classes doing early childhood, but they don't want to do like, how can I say this now? Like you're doing like grade 5 to grade 2, right?
Grade 5, grade 2. You talking about early childhood?
Yeah.
Yeah, like elementary school, basically.
Yeah.
But like, like some early child majors, they just want to do
Yeah.
pre-K, 3K.
That's what I'm saying. Like, so this student wants to do from birth to like up to like grade 2. So like that's like an early thing, right?
Right.
But Lehman don't got that, so they got to go to city for that. That's the issue. Yeah.
I don't mind, honestly. I really don't.
Yeah.
Like,
But
like
but if you're going
elementary.
up to grade 5, then you straight.
Yeah, I mean, I work out of school right now.
Yeah.
You only deal with second grade.
Nice.
Yeah, so I mean,
Yeah.
I'm just doing this so I can get the my degree, and then they'll hire me
Right.
as an actual teacher.
Yo, whatever you do, don't stop. Get that master's.
But yeah, that's fact. I'm trying to go right away because I know if I take a break, I don't want to
Yeah.
get the masters anymore.
Nah, they're gonna force you.
They're gonna force me.
Yeah, in education, you forced to.
I know, like they don't because like if you don't care about doing administration, like that's why a lot of teachers told me, like if you don't want to do administration or anything like that, just don't get your masters because then you're not gonna use it.
Which school is allowing them to rock with a bachelor's? This is a charter school you're talking about.
It used to be a charter. Well, I used to work at a charter school,
Like, cause DOE is on some next level, like you need a master's thing.
but they'd be paying money.
I mean, yeah.
I don't know.
Yeah,
I hope so.
there's a pay jump for it. Yeah,
Okay.
most stuff. Yeah. But then what sucks is that there's like a gun to your head, like, yo, you got 5 years to do this or else kind of type of nonsense.
That's true.
But the master's program shouldn't take you more than like maybe a year, maybe 2.
Yeah, no,
Unless you do something like crazy, like say you do like English education for undergrad, like for your bachelor's, then you decide, you know what, I'm gonna be a bio teacher.
okay.
Now you gotta take all them science, like that's gonna, yeah.
Stephen Powers told me, he was like, oh, like he finished a 3-year program in 2 years. Anyway, and it was like, you can definitely do that. Anyone can do that if you just put the time in.
Yeah.
You remember when you said you drove our lowest grade?
Yeah, I am.
So maybe you see how I didn't take the test too?
And that's what drops. Yeah.
And can I please know my grade for this one? Cause I tried checking, but it didn't allow me.
Oh, snap.
So I don't have all the data right now, but just for like the test average is about like 57, But like, you take that, you get half your points back, I didn't even look at your homework yet, so that's not even factored into it and all of that, and then the final's not even there, so this is all hypothetical. Yeah. You're welcome. Yeah, let's look at this question real quick. All right, so let X be a random variable that represents the hemoglobin count in human blood measured in grams per milliliter. In healthy adult males, X has an approximately normal distribution. The population mean mu is equal to 15.1. And a population standard deviation of sigma is equal to 2.9.
Got everything.
Got you. So suppose a male patient had 15 blood tests, so N is equal to 15 over the past year, and the sample mean X bar was equal to 14.8, right? With a level of significance alpha is equal to 0.05, right? Determine whether the patient's hemoglobin count is lower than the population average, right? So the first thing that I want you to do, right? State your null hypothesis and state your alternative hypothesis. Your null hypothesis, you could very simply just tell me mu equals 15.1 and I'll be happy with that, right? Your alternative hypothesis is always the question, right? And what's the question here, right? Like, is the patient's hemoglobin count lower than the population average, right? So I could have swore I wrote that there already, but whatever. So this would be mu less than 15.1. That's it, right? That's my null and my alternative hypothesis. That's step 1. Step 2, I want to know what type of test this is, and it's always going to be a z-test. If you want to know why though, it's because I know what sigma is. All right. Anyway, continue. We're going to have X bar minus mu over sigma over the square root of n. X bar is 14.8 minus the mean, which is 15.1. divided by the standard deviation, which is 2.9, over the square root of n, which is 15. So the calculator, tell me what y'all get.
-0.0267.
0.0267.
1023.
All right, I'll take that. So then now, step 3. I want to know what is my p-value.
I got -3.4.
Let me see.
Oh, I forgot to put the division. At the bottom.
Yeah, I got 400. Yeah,
I forgot to put the one. Division at
I
the
got
bottom.
465.
Multiply 2.9.
Oh gosh, it happens, it happens. So now look, the p-value is going to be the probability of your z, right? And remember, just copy whatever your alternative hypothesis has, right? So my alternative hypothesis is less than, right? Right over here. So my sign for my probability or p-value is going to be less than. They match, they're the same, right? And then just copy down the number that you got. Negative 0.465, whatever, right? And after that, draw your distribution. Just like that. In the middle right here, this is 0. Right? Left-hand side, this is negative 0.400. Yeah. And I want to shade it to the left. Right? So now imagine I'm like standing here. Right? So we're gonna do what? Norm. And then the CDF. No. Gonna ask us for our mean. In this case, it's gonna be 0. We're gonna ask us for a standard deviation. In this case, it's gonna be 1. You're gonna ask me for my lower bound and my upper bound, right? What's my lower bound? What's my upper bound? Negative what?
Negative 0.465.
Infinity. Negative infinity. So negative 1 E99. What's your upper bound?
There's negative 0.4.
Exactly.
Let's be in the middle. So 0.4 is to your
Right. Right.
and then the infinity is to the left.
Exactly.
Because it's less than the 0.44.
Mhm.
So it's any number that's less than 0.4, blah, blah, blah.
Right.
So that'll be the infinity for the dividend.
Mhm. That's it.
Okay.
Just a little bit. But when you practice it, it'll come back.
Yeah. That's why I keep doing this big video thing.
Mhm.
I kind of really get it.
Yeah.
And standard deviation is 1.
Right, because it's a Z. Yeah. Remember we did the Z formula, we switched it all the information to Z here.
That's what I mean, automatically goes to 0.
Yeah.
Standard deviation always goes
Yeah.
to 1.
Mhm.
Hold,
Mhm.
always for the Z test.
Mhm.
Like when you put it in normal CDF, it's always gonna be mean 0, always gonna be standard deviation 1.
Mhm.
So for the binomial, it's PDF too?
Binomial is for PDF and CDF. Yeah, we use both. But for normal distribution, we only use the PDF. We don't really use the CDF. But we could. Okay. Now, but what's the p-value that you got? So second distribution. We'll go down, go across the distribution and go down to normal CDF.
0.65542.697.
Say it again?
0.655. 421,697.
Okay. So now, you agree, Brandon, before I continue? That number?
No, it means.
Mhm.
Oh. Because they're supposed to be zero, negative 0.400.
Yeah.
But negative sign. I got 0.33483. Yeah, that 0.344.
Which I got. Let me do it. See what I get.
We got the first reading thing, 0.344. One, four down. What did you say? Um, 0.44. So 0.34438.
So I got 34439.
Yeah.
Well. Next, I want to do the p-value versus alpha. And then the alpha is what? 2.05. All right, which is bigger, 34 or 5? Good. So if your p-value is greater than alpha, what do you do? Do you reject or you fail to reject?
And
And that's it. If you want to go on further and be like, there is not enough evidence to reject the null hypothesis, you could tell me that as well. In addition to, not in spite of.
how many questions do you define?
Like 9. But you've seen all the questions already. It's the last one. It was everything from last week and this week. That's your final. You can go to the study halls. I'm sorry?
Alpha, is it always given to you?
Always, always.
Filter that could be step five,
Mm-hmm. And that's it.
and the P value is step four,
Mm-hmm.
step three would be the graph, and
Mm-hmm.
then I got steps one.
Yep. Okay. What do you work as?
East Side. I
Nice.
work at a shelter.
Nice.
I'm in security.
Okay.
It's cool, calm. Don't really do much.
Real quick. Everybody on the recording, have a good night. I'll see y'all next week for your final.